Morning. Wait, you haven't seen it yet. It may suck. Good morning, good morning. She's giving me signals in the back. With those lights, I have no idea what she's signaling. We may be here for 2 hours. I was going to do this on my MacBook Pro, but since Xamarin acquired Microsoft, I figured I'd switch over to... We're going to talk about test-driven development, and I think the first question when you're talking about test-driven development is whether the presentation is for you. Test-driven development on mobile is essentially test-driven development. There are a couple advanced use cases that we will not be covering where you run into some issues on mobile because of the difficulty with working with reflection. However, that will not come up today. So if you have a lot of experience already with test-driven development, there won't be much new here. If you don't, hopefully all of this will be new, and hopefully all of this will be clear. I've got about 10, 15 minutes of slides, and then we're going to do coding to see what this is really like. One of my objections to most presentations on TDD that I've seen is that they'll show you one example, and then they'll say, carry on like that. And it's the second one that's tough as far as I'm concerned. So let's get right into it. In 1753, the Liberty Bell was commissioned. It was taken to Philadelphia. It rang once and it immediately cracked. I don't know about you, but I've written software like that. It's not a surprise that not all our software is up to what we would like, because most of the time we are almost literally stumbling in the dark, trying to figure out what our code does and what the interactions are between the various parts of our code, but specifically starting with unit tests that, is this code doing what I think it should be doing? There is the problem of trying to determine the interaction among different parts. We know that testing can make a tremendous difference, but what kind of testing? Working backwards in the development cycle, there's user acceptance tests. That's where you hand your product off to your user and say, is this what you wanted? Now, hopefully you've been talking to your client before this point, but user acceptance testing is when they really begin to hammer on your application. UI tests you'll be hearing about later in the day with Test Cloud. We will not be talking about UI testing. Integration tests are when you put your unit tests together and see how your different parts of your application work. And unit tests are what we will be focusing on. Most of us know that unit tests will help. Most of us are under deadline. It is true that when you first start using unit tests, and especially when you first start doing test-driven development, that it can take longer than if you don't do these tests, at least in the short-term development part. If you consider maintenance, however, then it never takes longer. And once you get pretty good at unit tests or test-driven development, and those are really slightly different things, we're going to talk about that. Once you get good at it, many of us find that it's faster than doing our coding without tests. But you can see, and there is certainly true that there's a conflict, and many of us are pushed kicking and screaming into doing unit tests. And even when we know that unit tests are beneficial, there are always many reasons not to do them. This is my favorite. I don't know who put this up on the net, but I just love the idea of an O'Reilly book called this. Unit tests at some point become critical to your application, and hopefully you're getting there before you need that, you should pardon the expression, lifeline. I'm not even going to comment on this one. I'll just let you read it. Here is the spec for what we're going to be considering. This is a project tracker. Each of those rectangles represents a different project you might be working on. As you click from one to the next, it begins timing. And what's critical here is that you can go to one project and then to another and go back to the first. And the first has to keep a cumulative time. We will not actually build this, but it will drive the tests that we're going to be talking about. Before we get to that, however, let's draw a distinction between unit testing and test-driven development. Both unit testing and test-driven development use unit tests, which makes the distinction somewhat confusing. Let me see if I can pick that apart a little bit for you. In a unit test, the test is created after the code is created. And the purpose of the test is to ensure that you have built what you expected to. So typically the process is, I sit down at my computer, I figure out what I want to build, I build it in code, and then I create a test to make sure I got what I expected. That's unit testing. Test-driven development turns that on its head. The unit tests are created before you write any code. That makes all the difference in the world. In test-driven development, the design of your code is captured not in your code, but in the unit test. And then the code implements that design. The code becomes very straightforward and fairly simple once you have a good unit test. So test-driven development really inverts the way we're used to coding, and that's why it takes a little while to get your head around it. Let's talk about some practical aspects of TDD. Those of you who arrived a little later than I said it, we've got 10 minutes at most of slides, and then we're going to look at code. So don't panic. The main cycle of test-driven development is what's called red-green refactor. You start with a failing test, and that's very important and easy to skip. The reason you want a failing test is that when your test passes, you know that you have, in fact, made the change you thought you made. If you start without testing or with a passing test, then your change may be incidental or a side effect. So you always start with a failing test. That's called the red phase. You then go to the green phase where you write enough code to make that test pass. That gives you the ability to refactor your code and use the test to make sure that the refactoring doesn't break anything. And then you repeat the cycle, as far as I can tell, indefinitely. Unless you actually want to ship your app, then when at some point somebody comes along and says, knock it off. There are a few guidelines that have proven helpful in test-driven development. There are no TDD police as far as I know. So these are just guidelines. But these are very powerful guidelines. They've been extremely helpful for a lot of us. One is that you do not write application code until you have that failing test. The second is that you write just enough test code to test one thing. And then you write just enough application code to make your test pass. And I'll reinforce the idea once again because it'll really take a few times for it to make sense, that it's the unit test that drives the coding in test-driven development. This is one of those things like the international date line. When somebody shows me the international date line, it makes perfect sense. Then they leave the room and I have no clue what they said. It's like, I still don't get how it works. Unit test-driven design, that is TDD, test-driven design, is so different ultimately from the way we're used to coding that it really takes doing it to make it make sense and sort of hanging in there for a while with doing it for it to make sense. I recommend being fairly rigid when you first start doing TDD. It's much like when we started with MVVM and somebody came along and said, there will be no code behind. And for a little while, we did that, right? I mean, whatever it took to get everything out of code behind, we did. And then some of the leaders in the field, I remember particularly Laurent saying to me, You know, if you have something in code behind it, it's like not the end of the world. Right? I got it right? Okay, good. So these guidelines, I think, are worth following until they're dopey, in which case, forget it. I used to work for a guy who said the prime directive is don't do anything stupid. So, and you'll see today we will be a little bit rigid in how we approach it. Okay, asserts. Asserts are the heart of unit tests, whether you're doing TDD or plain unit tests. They say, am I getting what I expected? So I can assert that two values are equal, or I can assert that some Boolean is true, and you'll see there are a number of different asserts. It's dry up here. As a general guideline, you want only one assert per test. And the reason for that is that when you look at a failed test or a passed test, you want to know immediately what that test tested. If you have to go look at the test, or worse, debug your test, or take it apart, or step through it, you're already failing because it's going to take too long and you're not going to do it. By having a single assert for each test, when you look at the test failure or success, you know immediately what that means. Did I mention there's no leaving? One of the acronyms that's used for test-driven development is FIRST. It's a little forced as acronyms go. The first part of FIRST, if you'll forgive that, is that your tests must be fast. They must be, as we would say where I live, wicked fast. And the reason for that is if your tests are taking too long, you're not going to run them. They're going to be in the way of your development. By having extremely fast tests, you can test again and again and again. I know people who test after every line of code or after every couple lines of code. They want to know, are they on the right track? But certainly at the end of a method, you want to run your test. And you may want to run all your tests from time to time. And that can be hundreds or even thousands of tests. They have to be fast. Now, I'm not suggesting you run 1,000 tests after you write one method. But at the end of the day, you may want to do that. Or as part of your continuous integration, you may want to do that. Tests need to be isolated from one another. You don't want any order dependency in your creation of your tests. You want to make sure that you can run one test without any of the others, or you can run your tests in any order, or you can group them in any way you like so that you can run, for example, all your data tests or all your logic behind your UI tests or whatever the grouping is. And one test may live in other groups. So they should be totally independent. Secondly, or thirdly, they should be repeatable. If I run a test and then I don't change anything and run it again, I better get the same results. Because if I don't, that test is worthless to me. It hasn't told me anything I can rely on. Here's where we really push the acronym, self-verifying. What that means is only that your test should be unambiguous. It should test one thing, and we're going to talk about naming your tests to make sure that when you see the result, you know just what was tested. And finally, there's the issue of timeliness. Are you testing after you write the code or before? Today, we're going to be focusing on test-driven development, which comes before. There's a closely related concept to TDD, which is called behavior-driven development, BDD. We're not going to be talking about that today, but if you're interested in test-driven development, you may want to follow up by taking a look at the difference between TDD and BDD. All the cool kids these days are going on to BDD, but TDD is the foundation, which is why we're starting there. Okay, time for some live coding. What I've done is to create, before you got here, a simple Xamarin Forms application using a PCL. And you can see we have the PCL, we have the Droid, iOS, Windows, and WinPhone. Because I'm going to be focusing on classes that are in the PCL, I'm going to eliminate most of these projects for performance reasons. So let's take out the Win phone, and I apologize to the 4 of you who have one. And let's take out Windows Universal, which is more painful to do. We'll keep iOS and we'll take out Android because I'm a bigot. So now I have my PCL and one platform. We're not even going to use that platform, but it would seem naked without it. All right, the next thing that I want to do, I do have a mouse, is go over to my solution and say Add Project. Add New Project. And I'm going to go down to Test, and you can see there are a number of different types of test projects available to you. We don't care about UI testing. We're not doing that right now. We're going to take a simple unit test project. My project here is called TDD. By convention, I'm going to call my test project tdd.tests. And then I'll let Visual Studio create that. And what it does is it immediately gives me a sample test class, which is great, because I can never remember what the attributes are. So it shows it to you right away. Now, I'm a strong believer in well-named methods everywhere throughout my code, but especially in testing. Because when I have 100 tests and I go zipping through them by eye, it's not going to help me a lot to have them named test 1, test 2, test 3. I'm not going to know what they are. It doesn't even help a lot to use acronyms and shortened versions of names because you're still taking time to figure it out. So you'll see today, I'll have names like must show true when foo equals bar on Sundays, whatever it takes to make it clear that that's what you're testing. The other thing that I will often do is rename unit test 1 to something more meaningful, such as data tests or whatever it is that group of tests is, and I will break my tests up into files based on whatever arbitrary categories I have. Down here you see a test method. That's called test method 1. That name's got to change. The first thing that I like to do when I start a new solution is to create a test just to assure myself that everything's working. So I'm going to call this must pass. And this is going to be a very simple test to make sure everything is set up right. I'm going to say int expected equals 1, int actual equals 1, and here comes my assert. So I type assert, and IntelliSense tells me that there's a whole bunch of different asserts I can have. R equal of, not equal, is equal, fail, et cetera, et cetera, et cetera. Is true. I'm going to here say R equal. And then I'm going to pass in my 2 values. Now notice that my help on the bottom, I don't know how many of you can see that. Let me see if my magnifier is working. You can see that it takes 2 arguments, the value that's expected and the value that you actually got. Now, I cleverly named my 2 variables by those names, but that is certainly not required. So we're going to take off caps lock, and we're going to put in expected and actual. You can see why this test must pass. I'm going to open up, oh my, it closed. I'm going to open up my test, where are you? Come on. Do we have, bear with me, I apologize. I closed the, this is what I want. Test. Okay, we're just going to run it. I'm sorry? Oh, it's sitting right here. I'm just blind. Excuse me. Test Explorer right here. I should have run a test on my eyes. If you click Run All, it will build your application, discover all your tests, and run all your tests. There are other options where you can run just your previously failed tests or other groupings of tests. But I'm going to hit Run All since I only have one test. And it's going to build incredibly quickly, I hope. And it discovered my test, and now it's going to run my test, and you see that it passes. So now I know that my test environment is set up properly. I do want to drive home one thing. I used expected and actual because that's the order that they're expected in, but I could have named these anything at all. I could have called them Fred and Ethel. Most of you are not old enough to remember who that is. They were from the Lucy show, I Love Lucy. And that would work equally well. Okay, on. The first thing that I'm going to do, you'll remember our spec, which is we're building this project tracker, is start very simply. I like to go methodically, get it working, and keep it working. So I'm going to say that I want to make sure that when I start my test, that the test is active. Excuse me, when I start my project, that the project is active. That's my goal. So in my test, first I need to give it a name. When project started is active. Not a great name, but not bad. Okay, first thing I need to do is to create a project. We don't have a project. No such class exists. That's no problem. We start in the test, not the code. So I'm going to go ahead and assume that I will create a project. And so I can say project equal new project. The next thing I want to do is start the project. So I'll say project.start. Now remember, there is no project, so there is no start, but I'm doing test first. So I'm going to assume that the implementation will follow, and the hard part is right here. This is a very easy test. All I'm going to do is assert is true that project is active. Now, if I try to run this test, as you can imagine, it won't build. Because I don't have a project, it doesn't have a show method, and it doesn't have an isActive property. So I'm going to fix that. This is not the red phase formally. This is just the phase where you get it to build. So I'm going to go up to my project, and I'm going to add a new class called project. And notice that project is private, and can somebody, after this session, explain to me why Visual Studio defaults to a private class? Or can you tell me who did that so I can take them outside and beat them up? Thank you. By the way, Xamarin Studio defaults to public. Nah, 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 nah. Public class project. Okay, I now have a project class. So I know that I need a property to show that it's active. So we'll create a property. It's got to be Boolean, right? Is active, isn't active. So these are guesses at this kind of early design. And then I'm going to have a show method. So public, and since I don't have any other information, I'll make it void, not show start. And notice that I don't fill anything in. All I'm trying to do is to get my test to build so that I will have a failed test. Now, how to make this a non-failed test is blindingly obvious, right? You just say, is active equal true in your start. But this is a good exercise in making sure you have a failed test first. Well, it's a crummy exercise in it because it's too obvious. But we're going to be really, really rigid. So with luck, this will build and fail. And then we'll go on to more, well, it won't build. And the reason it won't build is that I didn't go into my project, even though I promised myself that I would, and say references, where are your references? References, add reference to the original project. Okay, let's try that again. Come on. Type or namespace project couldn't be found? Okay, we're just going to use a using statement to, where am I? Test-driven test. I'm in the project. I want to be in my TDD, and this is tdd.tasks. So let's go to the unit test, And we'll say, this is a little, I'm surprised this is necessary, but that's all right, using TDD, because it is a different namespace. All right, once more with feeling. Let's run them. And this is why I typically start with a fairly simple test. There's our red phase. Now we can go to our project, and we can just do whatever coding is necessary to fulfill that test, and no more. So here it's very obvious what to do. We're going to say, is active equal true? By the way, if you leave early, leave me your name, and I'll fill out the form, the evaluation for you. So it's a service I provide. All right, let's try building this. And notice it's the test, and they both pass. So that's the red through green phase. Not terribly meaningful with such a simple class. So let's say that we go ahead in our tests, unit tests, and we sit down and do a little bit of design work. Let me set this up with a test method and public void. And we think about the test for a bit and what it does. We think about the application and what it does. And we think, well, it's got to keep track of how long I'm spending on a given project. So let's create a test that says project has duration. That will test something a little bit more interesting. And I am very aware that I am what's between you and lunch. So we're going to end a little early, I promise you. Project has duration. So the first thing that I want to do is I want to be able to say to my test, start and give it some kind of start time, and end and give it some kind of end time. Now notice I'm doing this design before I write any test. I could mock up a timer, but that would take a while. So all I'm going to do is do an add seconds to my various times to make it easy in here rather than creating a timer, which will work, and it'll give me what I want. So let's say that we have a variable of type datetime called start time, and we'll set it to datetime, come on, dot now. Okay, we have start time. We're now ready to say project equal new project. So now we have a project. We can say to the project start and pass in the start time. Now there is no method in project that takes a parameter. That's why we're getting the red squiggly, and we'll fix that right before we do the red phase. But we're still in our design phase, and we're doing our design in the test. I'm going to keep hammering that point, that you do the design in the test, which is just so weird. And then we're going to say project.end, and we're going to tell it start time, add seconds, and we'll say we're going to add 60 seconds. Just, you only worked on that project for a minute. And we're now going to assert r equal, and what we're going to say is that the actual value, the expected value ought to be 60 seconds. And the actual value will be whatever the duration is in project. So now we've captured what we want in our design at this stage. We want to be able to start a project, end a project, and make sure we got the right amount of time. This will not build, as you can see, but we can go back to project and do a couple very simple things. We can say, well, we need a method, start. We're going to overload this method that takes a date time. And we're not going to fill that in yet. We're just going to create it. And we need a property of type, okay, what type? Well, we want to know how many seconds went by. So it's integer or double. We could start with integer, but it turns out that time spans and time entities are more comfortable with doubles. So we're going to make that a double. We happen to know that, and we don't need to be overly rigid. And then we're going to call this double duration, because you'll remember in the test, that's what we called it. So we should now have enough to build, and when we try to run the test, for it to fail. But we don't. Oh, it doesn't have a method for end. I created my start method, but not my end method. Sorry. So we'll say public void end datetime end time. I wasn't actually saying sorry to you. I was saying it to the compiler, but you can take it for yourself if you like. OK, run all. And this is just what we want, a failing test. So now we are ready to go. Now that we have a failing test that encapsulates our design, we're ready to go do the implementation. So we go up to project CS, which is where we are right now, and frankly, the implementation becomes almost dead obvious again. We know that we have a start that takes a datetime, an end that takes a datetime. Let's create a couple fields to capture that. Private datetime. Actually, I can do this in the wrong, and it'll fix my capitalization. I love that. Start time and private datetime. Oh, come on. End time. OK, then I come down to start, and I simply set this dot start time equals start time. And for the end, I set this dot end time equal end time. All right, I've now captured the start time and end time that was passed into me. All I need to do is set my duration. And I could, in my duration, call a method, but this is simple enough that what I'm going to do, if I can get my fingers to work, oh, come on. OK, there's my duration. In my duration, I'm going to create a getter. And this is read-only, so that's no problem. And I'm going to say, in my getter, return, and all I need to do is say end time minus start time. That returns a time span. We want to double, so I'll just say total seconds. Now, what has happened is that I started with a test that said, I'm going to pass you in a start time and an end time, and I want you to tell me how much time has passed. And then when I got to the code, I may have had to fool around a little bit. Do I need a variable? Do I not need a variable? But implementing this was fairly straightforward. That is, if it passes. If it doesn't pass, it wasn't so straightforward. It finds, and there you go. And notice it's now run 3 tests, and it's very fast. So I don't mind running all 3. OK. We're going to do one more. Because I think as you see these and they get more complex, slightly more complex, you get a sense of, OK, I know how to do the first one, but what do I do when I have a real project? So let's go back to our test. And this time we say, well, this is fine. We have duration. But that only works if we only go to the project once. What happens if we go to the project and then we leave, and we go to the project and then we leave? How do we get that to work? Let's cheat and copy this because it's the basis of what we want to test. So we'll say Control-Z, S, C, one of those. Control-V. And this one is going to be project can start and stop, and what happened? Woo! Can start and stop, and has duration. You can see I believe in long names. But then I can look at it right away and say, what failed, what passed? So we have a start time, new project. Then we have start and end. What we want to be able to do is start and end a couple times. So what I'm going to do is I'm going to copy this start and end, and then paste and paste again. So the first one's going to start at start time and end at 60 seconds. So we know that one lasted 60 seconds. So we'll drop that in here. That's my phone. That's a bad thing. Or it's somebody else's. Maybe it was somebody else's. Or was my wife going, oh my God, he's doing his presentation. Hang up, hang up. Okay, so we go away after 60 seconds, and then we come back to start again. And this time we're going to say that that started, let's say 120 seconds after the original start time. And we're going to end at 240 seconds. And all of this is arbitrary, but what we're looking to see is that we can have more than one start and end. So that lasted 120 seconds. And let's do one more where we're going to say start time.add seconds, and what we'll add is 360 seconds so that it starts at 3 minutes, and we'll take the end time. We need a paren there. Come on. Okay, I'm going back to my MacBook because the keyboard actually works. Okay, and we're going to end at 7:20. Okay, so now I have 3 start and stop. All I need to do is fix up my assert equal. So we're going to say it's equal to 60 plus 120 plus, and the difference on the other one is 360, so plus 360. That's what I expect my duration to be. I don't need to change the second part, it's project duration. I don't need to add anything to my class because I already have all these methods. Let's run the test. Remember, we're in the red phase. We expect it to fail, but why it fails and how to fix it is interesting. Did I run this or no? I'm sorry? Oh, thank you. This I did completely on purpose, I swear. It's important to recognize that you need a test method attribute on each of your tests, and if you don't have one, it won't run, which can be a nice, convenient way to take a test out temporarily. So we're going to say test method. Thank you for helping me make that point. Okay, there's our not run tests, and everything else passes. This one fails. Great, just what we wanted. Why did it fail? Well, if I go down to the summary, I click on the failed test. Let's do it here. And what it's telling me is that it expected 540, it got 360. Why the devil did it get 360? Well, we passed in 60 and set the duration to 60. Then we passed in 120, and that reset the duration to 120. Then we passed in 360, that reset the duration to 360. So we have a problem. This is not going to suffice what we've done in project. We need to have some other way of keeping track of that data. And the reason I'm belaboring this is, again, I haven't written any code. I'm thinking this through in terms of my test. Now I'm ready to work on the application. I need the concept of a segment. A segment is going to allow me to have a start and stop, and then I can have a collection of those segments, and that's going to let me manage this start and stop. So we're going to do this quickly. We're going to say that in our portable class, we're going to add a class called segment, and we know a lot about what this class should do. We know that the class needs to have a duration, which is of type double. And this is going to look very familiar because we've already figured this out. It's going to need a method, start and stop. And they're going to take date times, and they're going to set local variables. So I'm going to save myself some time and go back to my project and get that from my project. So I'm going to take duration, I'm going to take start and end time, I'm going to take, well, I don't care about that start, but I do care about this start and end. I'm going to take all that, copy it over to my segment, drop it into my segment, and go clean it up. So I already have my duration, that's great. I have my start and end time, don't need this one. And I have my start and I have my end. So my segment is capturing the same process that the entire project was capturing before. Now I go back to the project, and again, based on my unit test, I know that I have to be able to have multiple segments. So that makes this part pretty easy. I can say that I need a property, which is a list of segment, which I'm going to call segments. I can make that read-only if I like, because it's C#6, and I can initialize it, equal new list of segment. Okay, now, how am I going to keep track of which segment I'm working on? Because remember that my test says that I need to be able to send in start and stop times. So I'm going to make an active one. I'll say private segment active segment. Okay. We're going to come back to duration in a minute. In my start, instead of capturing the start time, which I'm doing in my segment now, what I need to do is create a new segment. And that's my active segment. Active segment, only if I spell it right, equals new segment. Great. And then I can tell my active segment to start and take the start time that was passed into me. Now that's pretty simple code, and it falls out, I believe, of the design that was captured in the test. Let's go down to end, and we're going to tell the active segment to end, passing in the end time, which I'm told I have to say end time and not end times, or people get scared. Pass in the end time, and then I want to say segments.add that active segment. Oh, come on. Okay. I now have a collection of segments. How do I get, remember we're in the project now, not the segment. How do I get my total duration? I'm going to go up to my duration property, and I can't any longer just return the simple start and end time difference. What I need to do is get all those segments. So I'm going to start by declaring a double called total time and initialize it to 0. And then I want to iterate through my segments and get their duration. So for each segment, in segments, I love statements like this. This is one of those statements that you come back to later and say, what? For each segment in segments, we're going to say total time plus equal that segment duration. And then all we have to do when we're done iterating through the segments is return the total time. Now, hello, what don't you like? Oh, it should be inside the get, sorry. Okay. We have progressively worked our way through the tests. We have taken the process that we used to do the original duration and refactored it to do multiple durations by taking that exact code and moving it up into our segment. We're taking the same data that was coming in, which is the start and end time, and with any luck at all, this should work. And if we have done this right, we've refactored the code, but we haven't broken anything we had. And we know that because we ran all the tests And they were quite quick, I hope you noticed. And they all turned green, which indicates that we have successfully captured the logic that was in the tests. We have captured that logic into the implementation. 15 minutes. We're going to take 12 minutes of questions and then let you go early for lunch. Are there questions? First of all, was this clear? Did this make sense? This was okay. So, oh, you know what? Let's do this. One more thing before I take your questions, which is to bring up this guy, because that lets me go to this guy, and the most important thing is to say thank you to people. Okay, do we have questions about any of this? Yes, sir. Oh, hang on one second. There's a mic because we're actually recording this. Now, are you going to edit out the ones I don't know the answer to? Because you can stop recording right now. Yes, sir.
So this is great for classes that don't have any data storage, but once you actually start getting databases involved.
Yes, once you start getting databases involved, what happens?
Exactly.
And the answer is you certainly can't wait to go get data from a database or data from the cloud. So what you do is you create a mock database. That is useless for testing your database, but very useful for testing everything else. So you create a little bit of code that generates known results, and you use dependency injection to say, during the testing, I'm going to use my mock. Then when I run the actual application, I'm going to use the real database. And then the mock is going to give you repeatable, expectable data. You can do mocking on the phone. It's not as straightforward on the phone as it is in other applications because typical mock libraries use reflection, and you can't do that on the phone. However, building your own mock for something as simple as this, as what we just described, is not terribly difficult. Now, I understand that there are mocking libraries that are coming to work on testing on the phone, and stay tuned. But at the moment, you sort of roll your own mock. By the way, there are fakes. I can never get the whole list. There are fakes. There are mocks. There are, Lauren, help me. I'm sorry? Stubs. These distinguish between, at the best I could, yes, this is getting in the mud. So all I'll say is it's the complexity of how much the thing will do for you. I tend to throw the whole thing under the name mock. Other questions? I feel like I'm on Oprah. Johnny, what?
Something that complements TDD very well is refactoring tools. So being able to generate classes and method signatures and stuff like that, and you can do that really easily in Visual Studio. But I think those kind of tools perhaps aren't present in Xamarin Studio at the moment. Things like generating classes and generating signatures from tests or things that don't exist yet be coming into Xamarin Studio.
Yes, you're saying there are tools that will take your tests and generate automatically the necessary classes. Do I have it right?
Yeah.
But as far as I know, not for Xamarin yet.
Yeah.
But again, now that Xamarin bought Microsoft, I really expect to see a lot more interest and therefore a lot more tools. And we've seen that interest take off. How many of you are independent Xamarin developers? None. Okay. The people I know who are independent Xamarin developers, and they're a better gauge because they see a lot of different companies, say that there's been a really big upturn in interest in Xamarin. And if you think about nothing else, if you had a crew of 20 developers and you had to pay $1,000 a year per developer per platform, so that was 40 grand to get started, and now the price point is free. And free is my favorite price point. Other questions? Way in the back. Well, she runs. I wish I could run like that. Oops. Thank you.
What if, to adapt this, let's say we actually have the top level executable, there's a whole bunch of logic in there. This works really well for the library itself. what if we screwed up and we actually had stuff that we want to test in the top level exe, if we think of the standard desktop? How would you, do you have any recommendations about how to go about it?
Sure. If I understand you, what you're saying is, okay, unit tests are cool, but what happens if I put it together and things fall apart?
Yeah.
And the answer to that, and this is a weasel answer.
Or more, how would we actually, let's say the duration and start time is actually in the very top level executable, not in our
Right.
library.
Right. Okay, here's my weaselly answer. If it's at the top level, but it's still you can still break it out as a unit, it's a method or whatever in the top level, then the test can test it. If the problem, however, is that this method A is doing some part of setting it, method B is doing another part of setting it, and each of them works fine, but when you put them together they break, that falls under namayab, because that falls under integration testing. And I don't mean to, to try to weasel out of it, but it's a different skill. Because integration testing requires putting everything together and seeing that it still works. And it's at a different phase in the development cycle. It may very well be that you do a daily integration test, but unit tests you're doing much more frequently than that. You're doing them through the day I typically run all my unit tests after I create each method. And different people do it at different times, but you're doing it a lot. You're doing it 20, 30, 40 times a day, whereas your integration test you're doing once, at most twice a day. Does that answer your question?
Yeah, that does. That's more at the continuous integration level you would have on your build box. That's where you do the tests.
And of course you are doing continuous integration, right?
Yes.
Of course. Clearly the bottom line here is on all these tests is the longer you wait to test, the more likely you're going to have things to fix. And the more likely it's going to take you time to fix them because it always takes longer to fix something that you haven't done in a while. One of the things I really like about unit testing, whether you do TDD or regular unit testing, is that it fails immediately, right when it's fresh in your mind what you were trying to do. And that, to me, makes the whole development process a whole lot faster. There was someone else in the back. There we are. How are we on time? Okay. Okay. Yes, sir.
My question was about, you said one assertion per test.
Yes.
If you have a business rule that maybe requires 2 or 3 assertions, do you view that as a rule that can be bent a little bit?
No. We will come after you, hunt you down, and ridicule you in the public square. I used to have, that slide actually used to say 1 concept per test. I really think it depends on what the 2 asserts are doing. If they are testing the same concept, but there's kind of 2 phases or 2 aspects or 2 faces to that, then I can see doing 2 asserts in 1 test. But recognize that if you do that, you may have to go in and see which one failed, and that's a bad thing. So remember in the first test where we said, is active equal true? I would probably go and make another test that says, when I turn it off, is active equal false? To be as thorough as possible. Now, on that particular test, it's a little bit trivial. I just got the signal that we're 5 minutes from lunch. So thank you all. I really appreciate your coming.